Hello. Right, thanks very much for the introduction, James. We're Nick Form and Chen Si-To from Oxford Semantic Technologies, and we're very excited to give you what's going to be a live demo of our graph RAG with RDFox example application. So just a little introduction on Oxford Semantic Technologies. We're an AI tech spun out of the University of Oxford in 2016 with a mission to commercialize some leading research in the field of knowledge, representation, and reasoning. We do that with our market-leading reasoner, RDFox. We have investment from Samsung Venture Capital and several FTSE 100 and Fortune 500 clients in our client group. And our mission is to help organizations find answers to questions that are both accurate and to do it quickly. And we do this by using a combination of human knowledge, data, and rules-based artificial intelligence. So I'm going to go explain in detail what I mean by rules-based artificial intelligence. But first of all, we're going to see the demo that uses it. So at this stage, I'm going to hand over to Chen Si, and she's going to give us the demo of the graph RAG backed by reasoning.
Thank you, Nick. Hi, everyone. Okay, so this is the chatbot that we created using LLM with also knowledge graph. So let's start by having the chatbot introduce itself, like what it does. Okay, so we asked the chatbot, what do it do? Because obviously we have that in the headline saying that this is a recipe chatbot, but I think it would be useful if we know what kind of question we can ask. So here we go. We have an answer from the chatbot saying that I'm here to help you find recipes based on your preferences, whether you're looking for meals with specific ingredients, dietary requirements, or cooking time. I can provide recommendations or even count how many recipes meet your criteria. If you already have a recipe in mind, I can give you the cooking instruction for it. How can I assist you today? Okay. So let's move on to our second question. Let's ask how many recipes it has. So we are using recipes as the database sits behind it. So this question will return the number of recipes we have in our database. So we have the total of 5,445 recipes in the database. And now let's move on to something more interesting. Let's ask for a recipe based on some ingredients. So let's say today I feel like having something that has fish and lemon. So I asked the chatbot this question. And after I send this question, there will be a series of action running behind the scene. For example, calling the large language model, calling the vector database, or using our RDFox to return a result for us. So here we go. The chatbot says that it has found a great recipe for us that uses both fish and lemon. It is called trout with crisp bacon crust, and then some description for the recipe. So as you can see, we are asking for fish recipe, and then the chatbot returned a recipe with trout. So when we say that we use LLM to create this chatbot, naturally you would think that, okay, it is not surprising that LLM knows trout is a kind of fish, but in our case, it is not. We are using an ontology behind the scene to support RDFox to do some kind of reasoning, and then we get this result. But the details, we will explain it later. And now let's move on to another question. Maybe I don't quite like this recipe, so I want to know, is there any other recipe that uses fish and lemon? So I can ask another question like this. Yep, so we just ask, can you recommend another one? So this time we don't have to tell the chatbot again which recipes we are looking for, and hopefully it will still know what kind of recipes what kind of recipe and what kind of ingredients we are looking for. And here we go. We have this new recipe. It is called salad niswas, okay. And yeah, and then followed by some description for the recipe. And okay, that's great. And so now maybe I really like this recipe by the look of the description, using tuna and lemon. So okay, now I want to know the instruction, and I can also ask the chatbot like this. And again, we don't have to tell the chatbot which recipes we are looking for, because we have stored the chat history behind the scenes. So now it finds the cooking recipe for us. Oops, there's something wrong with this. So this is one of the time when LLM get hallucinated, because it is supposed to return the cooking instruction for the salad niçoise, but somehow it just returns something else this time. Let's try it again. Hopefully this time it will get it right. No, it didn't get it right. So yeah, so this is one of the time when LLM get hallucinated. Actually, it is supposed to return the cooking recipe for this salad, but it didn't. So that's not great. But okay, now let's move on to the next question. We add a little bit of challenge for the chatbot. Let's see what it does. So we are asking for the quickest recipe that it has that contain the ingredient that we want, fish and lemon, and also we want it to be dairy-free. Okay, so now on top of our original request for a recipe that contains fish and lemon, we add another two conditions, the quickest recipe and also dairy-free recipe. And in order for this to happen, it requires reasoning from RDFox, and this will be explained later in the slides. And here we go. We have an answer from the chatbot saying that based on your preferences, I would recommend the lemon and pepper fish with roasted veg recipe, and then followed by the description for the recipe, and plus it only takes 2 minutes to cook, making it the quickest recipe. So now let's have a look at the actual web page of this recipe. So this is the lemon and pepper fish with roasted veg, and then for cook time, it only takes 2 minutes. And let's look at the ingredient. We have pepper, onion, courgette, garlic, oregano, olive, vegetable oil, breadcrumb, lemon, peppercorn, fish fillet, plain flour, medium egg. Egg is actually not a dairy product, so this is actually looking good. It fits all our requirement, and we also have instruction here if you really want to make it. And yeah, so let's move back to our chatbot. And so now let's try our last question, which is to ask the LLM or the chatbot to count the number of recipes that fulfill our requirement. If you remember in the beginning of the chat, we asked the chatbot how many recipes it has in total. So now we are kind of narrowing down the range. Let's see what it gives us. Okay, so hopefully it will find the number of recipes that are dairy-free and also contain fish and lemon for us. So it says that the system has 82 recipes that match your specific condition. So I've had the query open up in the RDFox console here that I'm showing you. So this is a Sparkle query, and we have dairy-free recipe here, and then we have the ROI for fish and also ROI for lemon. And when we run it, the number is 82, so it gets our requirement right. And yeah, so this is the end of my chatbot demonstration. I will hand this back to Nick.
Thanks, Tensi, and well done for being brave enough to run with an LLM in your demo. So what did we see there? We saw there's a convenient conversational-based chatbot user interface So we were able to ask questions and then ask follow-up questions. Not perfect success, and this is, well-established feature of LLMs that you'll all know well by now. Also, you've probably picked up the fact that we weren't just the LLM wasn't answering the recipes from its training data. It was actually, interrogating a specific knowledge graph. In this case, it was the BBC Good Food knowledge graph. So we've imported the recipes, the ingredients they have, the cooking instructions from that data set, and presented that for and the chatbot is to use that as a data source. So that we're using a RAG approach for that, which we've seen earlier tonight. So this is LLMs and RAG so far, but there's some extra ingredients here which weren't quite so obvious, which Chenxi made reference to. So first of all, there was some flexibility over the terminology. So using taxonomical information. So we were able to ask for fish as an ingredient, and we got back results with salmon. I think there was one with trout. Various times when we've run this, we've had mackerel. So there's an understanding there that, of the taxonomy of foods, and we can be more or less specific in what we ask for. And that's actually backed by RDFox's reasoning. We'll go into it in a bit more detail shortly. Let's have a look on this. We've got the slides first, I think. So if we go back to those. Then we also saw that there was these dairy-free and vegetarian, things like that we can add also with reasoning. So to go back a bit in history, before we had this chatbot-based version of this, we had a semantic search demo that used the same data set, where the requirement was, again, to find recipes by ingredients to included and excluded, and culinary preferences. And we exposed that with a faceted search. So the user had to, click and choose and find the attributes, the facets that were important to them over there. And that was based on taking the knowledge graph, loading it into RDFox, using a public taxonomy for the description of food. So that was representing the domain knowledge about food, which ingredients are in which categories and so on. And we tagged up the ingredients that were in the recipes data with respect to the terms from that taxonomy. And then we defined some additional advanced reasoning for defining high-level culinary concepts. Here's a little picture of the taxonomy. So, we've got what we've imported encodes the knowledge that, for example, salmon is a type of fresh fish, which is a type of fish, and we trace that back up to fish and seafood. So this is how we are able to ask questions, at different levels of the taxonomy. The actual reasoning makes sure that all of these ingredients are included. So let's go over to the RDFox console. So here's an example. So this is our Explorer. You can see the nodes represented as these rectangles and the edges by the arrows. We've got the recipe here, which is a sea bass recipe, and it has sea bass as an ingredient. But not all of these edges are equal. So some of them come from the original data set, the BBC Good Food. Some of them come from reasoning. And if I turn the highlight reasoning feature on, the ones that were there originally fade to the background, and the ones that have been added through reasoning are highlighted. And so we can see now how, when we interrogate this, the LLM is able to find this recipe as a fish recipe. So that's not the only place we've used reasoning. We have also used these rule-based enrichments to define concepts like a vegetarian meal or a dairy-free meal. So vegetarian, a recipe is vegetarian if it contains no meat or fish. So this is using negation in RDFox, which is one of our unique powers. The absence of information is used to conclude extra information. So let's have a look at that. So I think if I skip along to this tab. So here we see the recipe that was the fastest that we ended up with it surrounded by its ingredients. And we've got this additional tag on here saying that it's a dairy-free recipe. Once more, we can highlight that that dairy-free categorization of this recipe has been added by reasoning. And because these are reasoned edge, we can actually ask RDFox for an explanation of that. So if I ask for that, what's the explanation of that edge? So this is the explain interface in RDFox. So at the top of the screen is an expression of the fact that we want to have explained, the fact that the lemon pepper fish roasted veg recipe is a dairy-free recipe. You know, tell us, RDFox, why you think that. And what RDFox gives us is this view, a proof tree, which has all the supporting information so went into this. And down here, we can see the actual rule in detail. So you can read these rules. It's first of all comes the conclusions. This is called the head. A recipe is a dairy-free recipe if the following things hold. So first of all, it has to be a recipe. That's a no-brainer. But here's the negation part. So we look for all of the ingredients of that recipe using the has ingredient match predicate. And we check that none of those ingredients is a non-dairy free ingredient. And if that's the case, so we can't find any non-dairy free ingredients, then we can conclude that the recipe is dairy free. So this is like very useful. We can get, not only are we getting the RAG approach allowing us to look back into the graph so we can go and corroborate the information, but we can come into the knowledge graph and see what's the reasoning that's supporting any of these derived conclusions. So how do we... So yeah, the extra step was to get to the RAG approach. So we took the recipe chatbot, which you saw, a vector database, so that we could transform the user's search term, key terms in their sentences into IRIs, an LLM, obviously, to do entity extraction, function calling, and question answering. And then finally, RDFox, which is bringing the reasoning and the Sparkle API, the Sparkle query evaluation. And we can look at just one flow through this journey, how we produce the answers. So the user has asked, can you recommend a recipe that uses fish and lemons, with fish that uses lemons? Before any of this is happening, ahead of time, we load up RDFox with all the facts and the rules that we want it to apply to those facts. And the reasoning takes place as soon as we load that data. So as soon as we've got the data and the rules together inside RDFox, it calculates all of the logical implications of that rule set applied to those data, so that the next time we speak to it, we ask any queries, we query the fully expanded set. So yeah, when we actually come to the user running the query though, the first step is entity extraction. We send that to the LLM. It identifies fish and lemon as being key terms in the user's questions. We then send those to a vector database to turn them into IRIs so that we can speak to RDFox about those things directly, because it knows IRIs and RDF. And then we come to function calling. So we did originally, when we were playing around with this, think, well, LLMs are pretty good at translation. We could just get the LLM to basically translate the user's query intent into Sparkle for us. And that did actually work. So GPT-4, I think, was able to give pretty good, reliably good Sparkle queries matching the user's intent. It just took a long time. It took like 40 seconds just for that step, and that's only one step. So this is longer than a user would want to wait. If we downgraded to 3.5, it was quick enough, but this query wasn't good enough. So instead, we followed the approach of function calling, which we saw in Adam's talk as well. So projecting down the knowledge in the knowledge graph into a set of functions and presenting them to the LLM so that it could tool select. So to answer this particular query, the LLM would select a rule which expands to this Sparkle query. So we can see here that we've got it's a recipe. We've got the IRIs for fish and lemon that we were extracted earlier, and we limit it to 1 to get back one suggestion. We get in this example we get the trout crisp bacon crust recipe, and then we finally send that back to the LLM to compose that into a nice piece of prose for the user. And we do that, and the chat continues. The next time round in this chat, the LLM selects the function for getting the instructions for a specific recipe. So that's the graph RAG with RDFox demo. In conclusion, the reasoning we find is a powerful force multiplier for graph RAG system. It gives greater control of the factual content because you can expand, you not only can control the knowledge graph, but then you can put your human expertise expressed as rules into the system and have all that enriched data available, and thereby leveraging expert human knowledge. Thanks very much for listening. I'd be happy to answer any questions. So Chen Si, and while we're doing that, if anyone wants to download RDFox for free or sign up for our free reasoning workshop, then grab the QR codes off the screen while we're going through the questions. Thanks.
Hello there. I've got three questions, two of which are a direct result of it being live and one of them an actual question. The first one, I was counting off screen. So 6 seconds to return hello, generally about 12 to 16 seconds to return an answer to your other questions. So you've chosen not to use a Wally Watcher. What's the longest time that I would expect to return an answer as it's querying, going down its cascade of understanding NT extraction, formulating SQL query, and then backward on?
Well, I think the times we saw today are kind of representative of what we've been seeing. I think sometimes the OpenAI, which we're using here, is under more or less load and gets back to us faster. I don't know, Chen Si, if you have any specific worst case figures that you've seen?
So for current process that we're using, the maximum that I have tested mostly is around like 20 seconds maximum. So that I would say is quite a good amount of time for returning an answer, because you have to go through like many processes like LLM and then go to vector database and then Sparkle endpoint and then go to LLM again. Yeah, so 20 seconds is around 20 seconds, I would say. Mm-hmm. Yeah.
Thank you. The second one, so when it didn't quite do what it was supposed to do on your live demo, you basically asked it the same question again. How does it respond to prompt engineering within the chat?
So we have stored a chat history in the background. So every time when there is a conversation and and an AI provide for an answer, and then we have LangChain using the utility called memory, and then store and summarize the chat history. And then every time we ask a new question, we will also send the chat history to the LLM. So if I repeat the question again, he reads through the chat history. Sometimes it will get it right, and then it will return like a new the answer that we are expecting to see. But sometimes it doesn't, like what we just saw in the live demo.
That's my point. Why didn't you re-engineer the prompt that you were saying? If you didn't get this right the first time, please tell me how to explain lemon and trout.
Yeah, because the purpose of the demo is to show that we don't really have to keep our question like very detailed. Like I don't have to tell it again what is the instruction for that particular recipe. I wanted to know what was the question that I asked, and then find an answer for us. I could do that. It would definitely return like a right answer, but I don't think that's the whole point of this demo. So yeah.
I would disagree that that is kind of the point of the demo, but that aside. So the third question is, it has the chat history in there. You asked it what were the conditions of your dish. Your dish, ultimately, you said were fish and lemon. It returned trout and lemon. Additionally, on top of that, you restructured the conditions to include dairy-free. And yet it returned, as we saw, kind of trout and lemon. At which point in that chain does it make the decision that these were the conditions? Basically, it came back as a human of, yes, we were talking about trout and lemon, but if we're being factually accurate, you were talking about fish and lemon, and ultimately you put an additional condition of dairy-free.
I think in the end, the query that we ran, that Chen Si showed, that had 82 answers, that was based on fish and lemon, not trout and lemon, right? With dairy-free as as an extra condition. So, and then we showed that was the same answer that we got. So we could show the Sparkle. Well, we did show the Sparkle query that had those conditions. So I think at that point it had remembered the conversation that we'd been having. It had woken up from its stupor and got, we picked up what we were getting at. So.
Thank you.
Any more questions? Hopefully not on the other side of the room. There's always one, isn't there? To do the trip hazards now.
Thanks very much. I was interested in where the rules come from, and I think I've picked up at the end that that's where your human expertise gets added into the system. Is there any kind of scope for automatically generating those rules somehow? So maybe I'm not sure exactly how it works. Do you have to define them as Sparkle queries first?
So the language that I was showing in the explain interface, so there was an encoding there that it doesn't look like Sparkle. It uses had IRIs in it. That's data log. It's with some syntactical shortcuts. But somebody that's you know, capable of writing Sparkle would be able to adapt to the syntax of data log quite readily. So to answer the question, yes, these are human. This is human knowledge that we're trying to put in, and human expertise. It's possible to generate results, but then they have the same. You know, it would be possible to generate data log, but they have the same vulnerability to hallucinations. And what we're trying to do is protect ourselves against that with the RAG. So here we really can take out the human expertise and encode that very closely. And a couple of cases that so here we did, what was our expertise? So vegetarian meals don't have meat or fish, so that's not a particularly narrow or niche piece of knowledge, right? We all know that, but we could see this transferred into in industry. The ways that certain items from my product catalog can be correctly combined, can be configured, which is compatible with which. That's a piece of human knowledge that we people in the organization maybe have, and we can encode it very specifically, and we get a truth preserving kind of chain of operations, so we don't lose that with the explainability, so which we do sometimes lack with LLMs and machine learning in general.
Okay, cool. Thank you.
No problem. Thanks for the question.
This is a slightly technical question, I think. Can you comment on the interplay between the LLM and the reasoner, because they both use completely different kind of approaches to thinking, or reasoning, I should say?
Yeah, so the way I see it is we've got high quality data that we trust. So it's very trustworthy in the knowledge graph. We've spent time to make sure that it's high quality, wherever it came from. It might come from document extraction, something like that. We trust the rules that we put in because they've been absolutely corroborated with experts. And we don't want the LLM going off, making things up and subjecting us to hallucinations. And so we're trying to use the RAG approach to keep it on kind of guide rails. So we love it for its fluency, the flexibility the user gets in the way that they phrase their question, and not having to learn our a specific layout of buttons and checkboxes to be able to get the data that they want. But yeah, in the end, it's turned out to be quite simple. If you accept RAG as an approach, reasoning really just does kind of improve the situation, because we can just put that reasoning knowledge into our knowledge graph. It gets better, it gets enriched with that human knowledge, and we can then use the knowledge graph directly, or as we saw, we can use the LLM to access that. So yeah, it's not a really tight combination of the two models, but I think actually quite an effective one in the end. A simple to build, and I shouldn't do my colleague here an injustice by saying it's simple to build, but relatively simple to put the two things together and get something that's greater than the sum of the parts. So thanks for the question. Hi.
So I'm just wondering, how people could use or utilize your chatbot. For example, now I'm a company and I have my knowledge graph. How can I use the chatbot RDFox? Because the examples that you showed, about a knowledge graph about food recipes, but I have a different knowledge graph from a different domain or whatever. So how can I use RDFox? Do you provide any kind of automatic way to do this pipeline with the?
So this is not available as a product altogether today, but we sell RDFox as a product. So yeah, you try it out here. It's very easy to use. So you would bring the data and you'd bring the expertise, which might come from public sources. So the taxonomy that we brought in about food knowledge, that's a public data set. Anyone could use that, and you can, because these are RDF data sources, they're very readily imported into RDFox, and then we can directly use them to do reasoning in a lot of cases. So, but yeah, you would basically download RDFox, set it up on your machine, import your data onto it, and build. We could show you how to build something very similar.
Yeah, but the point that I want to focus here is like, do I need the human expertise from RDFox for these parts that, for example, the rule generation or the rule base for these things, or?
So it's the rules that encode the human expertise.
Yes.
So we do need those to be written, yeah, by a human. So, but the benefit of that is you get full control over what conclusions are going to be arrived at in the system, and you get explainability. So, were you looking for something that would again you'd be able to generate the rules automatically? Yeah.
Because without it, I don't think there is gap here between if people could use the chatbot or this.
Yeah, so the chatbot's not integrated; it's built on top. But yeah, I think again we say if you allow a machine to generate the rules, then you're kind of giving over control somehow, and you're exposing yourself to hallucinations or errors in those rules. And look, of course, humans are going to get errors in the rules, but over time we can correct those, and using the explain feature actually is a really good way to look for conclusions that we didn't expect and trace it back to errors in the rules, and over time improve the quality. So thanks for the question.
Great. I think that's all we've got time for. I think the hint of the cleaners kind of working around the periphery of the room perhaps is giving it away. But a big thanks to Nick and Chunzi. Really fantastic presentation.